today's lecture. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The lecture series that I am covering is for the subject Embedded System with the subject code KOE 062. Today the topic that I am going to cover is the discussion of different issues in hardware software co-design. So, what is this hardware software co-design? Whenever we talk about any of the embedded product development, so there is always the mutual interaction of hardware and software. There is always a combination of these two things, that is hardware and software, which is very mandatory for any of the product development, because without software the hardware cannot do its job, and without the hardware there is no existence of software. So, this is how the software and hardware comes together to perform the basic functionalities of any of the product. But when we want to combine all these two, hardware and software, there are certain issues that we face. So, in this lecture we are going to discuss those issues which come into focus when we want to develop any product and we want to merge this hardware and software. So, let us go into details. So, this hardware software co-design is, we can say it is a problem statement, and when we try to solve this problem in real life, we may come across multiple issues in the design. So, what are those issues that we are going to discuss in this lecture? Some of the fundamental issues in the hardware software co-design are selecting a model, selecting an architecture and selecting a language. So, these three things are very important in any of the product development, and these are the things that create the issue. So, when we talk about the models, that means we are following some mathematical model that will give a face to the product. So, we have already discussed these models. When we talk about the architecture, then we have to see that what type of architecture we are following for development of the product. When we talk about the language means that the language that we are going to use in the software. So, these things are the issues. So, when we talk about the models and architectures, specification and the constraints together leads to implementation. So, this is the part of design process, and the models, that is the specifications, leads to architectures, that is the models are the specification part and architectures are the implementation part. So, models are the conceptual views of the system's functionality, and what are architectures? These are the abstract views of the system's implementation. So, whatever we do in modeling, that is implemented as a hardware, and that is known as the architecture. So, let us see what are the issues while selecting the model. So, a model is a formal system consisting of objects and composition rules. In hardware software co-design, the models are used for capturing and describing the system characteristics. So, using the models we can decide the system characteristics, and we can decide that what all the functionalities have to be put into the system and what type of modeling has to be done. It is hard to make a decision on which model should be followed in a particular system design. As you already discussed the model, so we can according to the requirements, according to the field of deployment of the product, according to the lifetime of the product, according to the complexity of the product, we have to decide that which model is most appropriate for a particular application. So, most often designers switch between a variety of models from the requirements specification to the implementation aspect of the system design. The reason being the objective varies with each phase. So, what is this point is saying, that it is very obvious that when we follow all the phases, that we go through all the phases of the product development. Suppose we start with the waterfall model, with a linear model, and at certain point of time at the later stages we understand that this is very important to understand the concept again and again, to visualize the need again and again. So, we switch to the iterative model again. At certain point of time, then we at the later stage we feel that this is not appropriate model and we can switch back to the waterfall model. So, there is always a constant switching between the models, like there are the different models like waterfall model, iterative model, spiral model. So, we can switch between these models during the development of the product. So, this is very important point, and that is why it is very important to select the model that is most appropriate to our application. We can visualize this situation using this example, like at the specification stage only the functionality of the system is in focus, yes we know that, and not the implementation information. So, when we are specifying the when we are placing the specifications, when we are understanding, when we are analyzing the various specifications of the product, then we are not focusing on the implementation, but what we are focusing on is the functionality. So, when the design moves to the implementation aspect, the information about the system components is revealed and the designer has to switch to a model capable of capturing the system's structure. So, this is how the models keeps on changing from one phase to other. So, initially we were very much comfortable with one model, but at the later stage when we go to the implementation part, then we understand that no, that this model is not appropriate for our application and we need to switch to another one. So, this is how the switching between the models can take place. When we talk about the architecture selection, the model only captures the system characteristics and does not provide information on how the system can be manufactured. So, this is the architecture part, that how the design has to be implemented, how the system has to be manufactured. The architecture specifies how a system is going to be implemented in terms of number and the types of different components and the interconnections among them. Yes. So, when we talk about the architecture, so the important point that we are going to consider is its cost, its area of implementation, its power analysis and its time critical conditions, cost, its heaviness, its weight. So, these all factors have to be kept into mind when deciding the architecture, when deciding the implementation part. Some of the commonly used architectures fall into application specific architecture class like controller architecture, while others fall into general purpose architecture class, that is the CISC, RISC, CISC etc., or parallel processing class like VLIW, SIMD, MIMD etc. We will look into a brief discussion of all these classes. These are the architecture classes, different types of architectures. So, most few commonly available architectures used in the system design are controller architecture, Datapath architecture, CISC, that is the complex instruction set computing system architecture, RISC is reduced instruction set computing, VLIW is very long instruction word computing, SIMD is single instruction multiple data, and MIMD is multiple instruction multiple data. So, when we talk about the controller architecture, it implements the finite state machine models using a state register and two combinational circuits. So, these are all the machine models, state machine models comes under the controller architecture. So, using these state machine models, we can control the various situations, we can visualize the various situations, states that a product goes from one to another during its development. The state register holds the present state and the combinational circuits implements the logic for the next state and the output. So, this is how the controller architecture is implemented. When we talk about the Datapath architecture, it is best suited for implementing the data flow graph model, where the output is generated as a result of a set of predefined computations on the input data. So, this is best suited where the output is based on the set of predefined computations and the which are dependent upon the input data. A data path represents a channel between the, what is data path? It is actually a channel between the input and output, and in this architecture the data path may contain registers, counters, register files, memories, ports along with the high speed arithmetic units. So, in the data path architecture these are the very important parts. Like when we talk about the registers, these are used to hold certain values, the intermediate results. When we talk about the counters, these are also used to hold the variables which act as the counting variables, which acts as the counters for in different applications. When we talk about the registers files, again these are set of registers which are used to hold certain data. Memories are very integral part of any of the product development in any of the architecture, because it is used to store the data, it is used to store the database. When we talk about the ports, these means the input and output ports, these are very much necessary to develop any embedded application. So, input and output ports plays a very important role, and obviously the arithmetic units, that is the AU. So, any of the processing any processing in the embedded product development requires arithmetic units, because the large number of data has to be processed, have to be computed, the various operations, the functions takes place. So, there is always a need of the various arithmetic functions to take place during the product development. The ports connect the data part to the multiple buses. Most of the time the arithmetic units are connected in parallel with the pipelining support for bringing high performance. So, arithmetic units along with the pipelinings can lead to the high speed achievement in the products. So, what is this pipelining? Pipelining is a very popular concept in the much advanced architectures, much advanced processors. In the pipelining, what is happening is a multiple processes takes place simultaneously. Suppose 3 processes goes on simultaneously. So, in any of the process there are the basic phases, like there is the fetch phase, there is the decode phase, and there is the execution phase. So, when the pipelining is used, then the first process is, when the first process is being executed, the second process is being decoded, and the third process is being fetched from the memory. So, this is how the pipelining works, that all the 3 processes work simultaneously. So, there may be a pipeline of many more processes in the higher order systems. So, this is how the data path works. When we talk about the FSMD architecture, that is the Finite State Machine Datapath Architecture, it combines the controller architecture with data path architecture. It implements a controller with data path, that is the controller generates the control input, whereas data path processes the data. So, these 2 important units, that is the controller unit and the data path architecture, these 2 combines to process the much more complex data. The data path contains 2 types of input output ports, that is one acts as the control port for receiving or sending the control signals from or to the controller unit. So, the control signals are always needed to control the various operations taking place inside the processor. And the second input output port interfaces the data path with external world for data input and data output. So, this is again very important. So, whenever we are developing any of the product, that product is not alone, but it is a combination of the various peripheral devices along with that processor, that is a part of embedded system, the complete embedded system. So, this is very important to interact with the peripheral devices easily, conveniently. So, for that the input output ports are very much useful in that case, and there are different types of input output ports that no need to go into those details, but as a general discussion, that when we are talking about the input output ports, that there can be the parallel port, there can be serial port, there can be the synchronous and the asynchronous communication ports. So, these they have been categorized in different categories. Depending upon the requirement, we can select any of the ports and we can use in that embedded application. So, input output ports plays a very integral role in interfacing with the outside world, in interfacing with the peripherals. The data path is implemented in a chip, and input output pins of the chip acts as the data input output ports for the chip resident data path. So, the input output pins are available on the chips, and those pins can be efficiently used to interconnect with the peripheral, with the outside world. VLIW architecture, that is the very long instruction word architecture. It implements the multiple functional units, ALUs, multipliers, etc. in the data path. So, this is a very important, very good architecture that can be used while implementing the higher order of data, the large data. So, in that case, the ALU units and the multipliers play a very important role. VLIW instruction packages one standard instruction per functional unit of the data path. So, this is how this architecture works. When we talk about the CISC architecture, it uses an instruction set representing the complex operations. So, some of the microprocessors uses the RISC architecture and few other uses the CISC architecture. In the CISC architecture, using a single instruction, we can execute much complex operations. So, the CISC instruction set performs a large complex operation with a single instruction. Example, reading a register value and comparing it with a given value, and then transfer the program execution to the new address location. These three processes, like reading a register value, comparing it with a given value, and then the third operation is transferring the program execution to the new address. All this is done using this C, J and E. Compare and jump if not equal. So, this is the how this instruction can be explained, that compare and jump if not equal. So, this instruction will compare the two values and will jump to the new location if they are not equal. So, a single instruction is performing three complex operations. So, this is the role of complex instruction set. The use of a single complex instruction in place of multiple simple instructions greatly reduces the program memory access and program memory size requirement. So, this is the advantage of CISC architecture. However, it requires additional silicon for implementing microcode decoder for decoding the CISC instructions. This is one of the drawbacks, that this requires the extra silicon implementation, it requires the implementation area. The data path for the CISC processor is complex. So, this is how the CISC architecture is used. When we talk about the RISC architecture, this means reduced instruction set computing system. That is, it uses the instructions which are much more simpler and can perform only one operation at a time. They cannot perform multiple operations like there was the case in CISC. So, like if we are moving certain data from one place to another, there are certain instructions which can do only this thing. If we are adding two datas, then there are instructions for adding two variables. So, these in this category, in the RISC category, though there are the availability of those instructions which can perform simple operations at a time. The RISC instruction set contains a larger register file for storing the operands and outputs. The RISC instruction set is designed to operate on registers. So, in RISC architecture, there is much higher usage of registers for storing the values, for storing the intermediate values. RISC architecture supports extensive pipelining. So, here since there are simpler instructions and these are performing the basic operations one at a time. So, obviously, we will always need some pipelining to be used so that the processing speed can be increased. When we talk about the parallel processing architecture, it implements multiple concurrent processing elements, that is the PEs we can say, and each processing element may associate a data path containing register and the local memory. Parallel processing architecture examples are SIMD and MIMD, that is a single instruction multiple data and multiple instruction multiple data, that is MIMD. Let us see what are these. In single instruction multiple data architecture, a single instruction is executed in parallel with the help of processing elements. The scheduling of the instruction execution and controlling of each PE is performed through a single controller. This type of architecture forms the basis of reconfigurable processor. On the other hand, the processing elements of MIMD architectures execute different instructions at a given point of time. So, this is the basic difference between the SIMD and MIMD, that in SIMD the single instruction is executed in parallel with the help of processing units, but in MIMD the processing elements execute different instructions at a given time, at a given point of time in case of MIMD. So, MIMD forms the basis of multiprocessor systems and SIMD forms the basis of single processor systems. So, PEs, that is the processing units in the multiprocessor system, communicates through mechanisms like shared memory, message passing. So, this basically MIMD architectures are beneficial when we are talking about the real time operating systems. So, in those RTOS there is much need of executing the different processes at a time in real time. So, in that case this type of MIMD architectures are very beneficial, and in that case the variables that the multiprocesses communicates with each other using a shared memory or the message passing. So, these are the important concepts of RTOS and we will discuss in further lecture. The last point is the selecting the language. The programming language captures a computational model and maps into the architecture. So, it depends that what architecture we are using and for that particular architecture which language is preferred. A model can be captured using multiple programming languages like C, C++, C#, Java, etc. for software implementations, and languages like VHDL, System C, Verilog, these are used for hardware implementation. So, there is a difference between the hardware and the software implementations languages, and then from these languages we can select for our purpose. On the other hand, a single language can be used for capturing a variety of models. There are certain models also that a single language can be used. Certain languages are good in capturing certain computational model. For example, C++ is good candidate for capturing an object oriented model. The only prerequisite in selecting a programming language for capturing a model is that language should capture the model easily. So, this is very important that whenever we are making any selection for the language, for the model that we are using in our application, it is very important to go through all the functionalities of the language, all the that is the libraries available with the language, so that we can make a wise choice with the language for our architecture. So, this is very important. So, this is how the different languages are used for designing our models. So, that is all for so today we discussed about the issues that we come across in the, so what were the, so according to the first slide, we were going to discuss this, how the model is selected. So, we talked about the during the life cycle of the product development, we can switch between the various models during the phases of the different phases of the product. We can also look into the architecture. There are various types of architectures available. There can be SIMD, MIMD, there can be the controller architectures, there can be pre-processing, the parallel processing architectures, there can be RISC or the CISC. So, depending upon the needs, depending upon the requirements of the product, we can make a wise selection with the architectures. Likewise, with the language also, we can make a selection with the language according to our models, so that the model is compatible with the language. So, this is how the issues in the hardware and software co-designs are addressed, and they can be solved by addressing these 3 points and making the wise choices between these models, architecture and languages. This is how making the wise choice between the models, between the architecture and the languages, we can avoid the issues that we come across during the product development between the hardware and the software designing. So, this is how we can address those issues, and that is all for the co-design issues. Thank you.